Well, today's lesson is about density, and I'm sure that you have heard the word density used in many situations, right? Like you talk about the dense forests and population density for those of you who do geography and so on. So let's look at what the objectives of the lesson today will be, and we'll be speaking about density in the context of physics. In this lesson, you will explore the relationship among mass, volume, and density. You will state the definition for density and its SI unit. You will use an experimental method of determining the density of a material, and you will solve problems relating to density of materials. I want you to look at these two photographs here, and photograph A and photograph B. Photograph A, and these are two crowds of people, right? And I would like you to answer this question. Take your pencil and write it down, which in your opinion, in which crowd is more dense? Which crowd is more dense? And you know, in this COVID time, we shouldn't find ourselves in any of these two situations, right? We must be careful and we must maintain our social distancing. But these are two crowds. And I want you to just take your pencil and note down somewhere which crowd you think is more dense. All right. I want us to take note and look at this demonstration that I'm going to do here. In cup A and cup B, I have two different liquids. All right, and I'll call them liquid A and liquid B. And I have the same volume of liquid in the two cups. What I will do, I will take these two cups and put them on this balance. This balance is balancing by itself. And let's see what happens. Remember, they have the same volume. So I'm going to take them, cup A, and put it in this one, and cup B, and put it in this one. Again, I want you to write down a note, which of the two liquids in the cup has greater mass. Which of the two liquids? Based on what you see here, they have the same volume, but I want you to tell me which of them, write down which of them has greater mass. What I'm going to do now is to take some of liquid B and I'm going to pour it in the cup until the two of them acquire the same mass. When they acquire the same mass, we would expect the balance to balance back again. All right? So here we go. So I will pour. Oops, I pour a little bit too much. I don't think so. I might have gone over a little bit, but I just wanted to get the idea that they're about the same mass now. It hasn't quite gone too far. And so here now, when they have the same mass, I want you to observe and to say which of them now has greater volume. All right? So liquid A and liquid B, when we put them on, right, you wrote which one had the greater mass when they had the same volume. And now I want you to say which has the greater volume when they have the same mass. I want you to take note and write those down. All right? Okay. So let's go and see what we have here. For the same volume, did you get this? That liquid A, when they had the same volume, liquid A had a greater mass than liquid B. Did you get that? Because what happened is that because liquid A had a great mass, the balance went down like this. All right? So liquid A had a greater mass for the same volume. So and liquid B had a smaller mass for the same volume. Let's see the other one. When they had the same mass, and we can see it now, this is for the same mass, we see that liquid B has a greater volume and liquid A has a smaller volume. So we looked at two things with these two liquids. For the same volume, we found that liquid A had a greater mass and liquid B had a smaller mass. And for the same mass, liquid A had a smaller volume and liquid B had a greater volume. Okay? All right. So I want to introduce to you now a term. This term is the term density. All right. Now, the density of a material, when you're going to find the density of a material, and one thing I want to emphasize, that we find density of materials. We don't find density of objects. So we will find the density of wood. We will find the density of plastic, density of rubber, density of glass, and so on. But we don't find the density of a shoe, or we don't find the density of an object, but we find the density of the material or materials that the object is made of, okay? So here we have specifically that the density of a material is the mass of the sample of the material divided by the volume of the sample of the material. So we take a sample of the material and we find its mass and its volume. And let's reflect on what we did in the demonstration here. We saw that when the volume of the materials was the same, that the mass of liquid A was greater than the mass of liquid B. When the masses were the same, the volume of liquid B is greater than the volume of liquid A. So based on that observations, those observations and the definition of density, I want you to write down which of the liquids you think has greater density, liquid A or liquid B. So you can just jot that down, and then now let's see which one. Would it be, is it liquid A? Well, it says yes, and liquid B, no, it's not. So liquid A has greater density, but we can move ahead and look at the reason for this conclusion. Now remember, density is mass divided by volume, okay? So when the volumes of the liquid are the same, we're dividing the mass of A and the mass of B by the same amount, by the same number, all right? The volume, say the volume is 5 cm cubed or something. Now, if the mass of A is greater than the mass of B, you're dividing a larger number by the same number and a smaller number by the same number. So this here, this value would be greater than this value if they have the same volume, but these two, this one is larger. The numerator is larger and the denominator is the same, then this would be larger. So the density of A is greater than the density of B. All right, so that's one. Let's look at the other, if the other one tells us that as well. When the masses of the liquids are the same, you are dividing the same amount by two different quantities. Now, since the volume of A is less, you're dividing a number by a smaller number, which will give you greater. If you divide 5 by 2, then it gives you 2.5. And the volume of B is great. If you divide 5.4, it just gives you 1.25. So given that the volume of A is less than the volume of B, but you're dividing the same mass by them, then the density of A is greater than the density of B. So we see that the density of A is greater than the density of B, and that shows itself when we did both same mass and same volume. All right? Okay. So let's move on. Let's do a little review then. Remember in the first instance, I asked you to jot down which one of these crowds you thought was denser, which was more dense or denser. All right. So here is what, here is a little reason. The crowd B is of greater density because more people, if you have more people, you have more mass, right? 10 people in a room or 10 people in an elevator, they have more mass than if 2 people are in the elevator. Now, let's take I'll keep with the elevator example. If 10 people are in the elevator, then they are occupying a certain space. So the volume that they are occupying, they have greater mass, and they're occupying the same volume so that their density would be greater. So here, the crowd of people, if I were to take this crowd and put it over here, is a whole heap of people packed in there. And this is less people in the same space than in crowd B. So crowd B is of greater density because more people, greater mass, occupy the same space or the same volume than in A. All right? And we see it, we talk about it all the time when we see things closely packed in. It's a boy that really dense. All right? You talk about dense forest. All right? You talk about dense forest, that means that the trees are all close together and well packed in. All right? Okay. So let's look at what is the SI unit of density. Okay, let's look at what is the SI unit of density. So remember, density is mass divided by volume, right? And we know that mass is one of the fundamental units in science, and the SI unit of mass is the kilogram. Okay, the SI unit of mass is the kilogram. And then we know that volume has a derived SI units, and I'm sure that you have done fundamental and derived units, and we get the derived unit of volume is the meter cubed, right? Because volume is length times width times height, and each one of them has an SI unit of meters, so when you multiply meter by meter by meter, you'll get meter cubed. So the derived SI unit of volume is the meter cube. And density is equal to mass over volume. And if you're dividing the quantities, you must divide the units as well. And so the density, the derived SI unit of density would be the SI unit of mass divided by the SI unit of volume, which would give you the kilogram per meter cube. All right, kilogram per meter cube. SI unit of mass, the kilogram. SI unit of volume, the meter cube. You divide them, kilogram per meter cube. And for those of us who can remember that we would write this in scientific notation is written as kilogram per meter cube. That's in scientific notation. All right, kilogram per meter cube is the same as that, kilogram per meter cube. Okay. All right, so we move on. Second, I'll do a second demonstration here. All right, now we might want to find, how do we find the density of a material? Suppose we have a material and we need to find its density. How do we go about doing that? All right. So if we wanted to find the density of a material, right, we will first of all get a sample of the material, right? Because remember, now we're going to find the density of, take a sample of the material. We're going to measure the mass of the sample. Then we are going to determine the volume of the sample. And then the density of the material would be equal to the mass of the sample divided by the volume of the sample, right? And we can determine the volume of the sample by a displacement method. What is that? Now, when you put, I'm sure when you know if you put an object in a mug or something with water, then the level of the water rises. All right? The level of the water rises. And that happens because the object pushes aside the water because the object has to make space for itself as it goes into the water, and it pushes aside the water, or the word that is used, it displaces the water. Now, when the object goes under the water, it displaces an amount of water that is equal to its volume. It can't displace less than its own volume, or it can displace more than its own volume. It displaces an amount of water equal to its own volume. And if you can measure the displacement of the water, how much water, what volume of water is displaced, then that will tell you what the volume of the object is. So here I have a stone, and we're going to find the density of the material of this stone. All right, so first of all, this is our sample of material, because these are this just comes from, if you go on to Palisados, you will see some huge, very huge rocks. So this is just a sample of the material. Then I will use my spring balance, and I will measure the mass, and I want you, as the operators, draw the screen, the camera close to and you see, I want you to note what the mass of the stone is, or the material. All right, I will just take a peek so I can see. All right, so this is the mass of the material. All right, I want you to make a note of that. Okay, and then we're going to take the stone, and we're going to, or the material, and we're going to sample of material, and we're going to immerse it in this mug with water. Now, as it is, the level of the water is at the 250 milliliter. Now, 1 milliliter is the same as 1 centimeter cube. So I'm going to immerse the stone in it, or and let's see where that goes to. That goes up to the 350 milliliter mark. All right? So we can look at our volume. The original volume was 250 original, and the final 250 cm cube, and the final is 350 cm cube. So the volume of our thing would be, so the volume is equal to 100 cm cubed. All right. So I hope you would have measured, and you would have written down all of these values here. So let's move on. So we have some, I did this, and for my thing, the mass of the sample of the material is around 220 grams. If you have anything little less or a little more than that, don't bother yourself too much with that, all right? Because that's a judgment call oftentimes. The volume of the water without the sample is 250 cm cube. With the sample, 350. The volume of the water displaced, and remember we said that the volume of the water displaced is equal to the volume of the sample itself. So the volume of the sample itself is 100 cm cube. So that's our data that we have here, and that's what we're going to use now to determine the density of the material of that sample. So the density of the material will be the mass of the material divided by the volume of the material. And we said the mass was 220 grams, and the volume is 100 cm cube. So we will divide 220 by 100, and we get 2.2 gram per cm cube. But remember, gram per cm cubed is not the SI unit. The SI unit of density is kilogram per meter cube. But because we measured the mass in grams, and we measured the volume in cm cube, and we divided a quantity in grams by a quantity in cm cube, we get units of gram per cm cube. All right. So we'll move on. Now, this can be shown, and maybe I would want you to try to see that you can show that 1 gram per cm cube is equal or equivalent to 1,000 kilogram per meter cube. It might look strange to you because you see in grams and kilograms and cm cubed and meter cubed, and you're told that when you're moving from smaller unit to larger unit, you divide and so on. So how come it is that a quantity in kilogram per meter cube has more than that? But when you do the conversion, which we may not have time to do right now, but you can ask or you can look it up and see how the conversion is done. All right? So 1 gram per cm cubed is 1,000 kilogram per meter cubed, and so the density of the material will be 2.2 gram per cm cube times 1,000, which will be 2,200 kilogram per meter cube. So the density of the material, this material here, from which this material here is 2,200 kilograms per meter cube based on our experiment that we have just done. All right? Okay. So that's a lot about what measuring density. So far we have looked at the relationship between mass and volume and density. For the same, if you have two materials and one material is more dense than the other, if these two materials have the same volume, then the more dense material will have greater mass. And if these two materials have the same mass, then the one with a smaller density will have a greater volume. We also saw that because the SI unit of density is the kilogram per meter cube, because the SI unit of mass is kilogram and the SI unit of volume is meter cube, and so you're dividing mass by volume, so you get kilogram per meter cube. And then we looked at an experimental procedure where we measure the mass of a sample of the material, we measure the volume of the sample of the material, and then we use those amounts in order to determine the density of the material. So we'll just look at some questions, right? Some questions. It says the density of liquid A is twice the density of liquid B. If you pour out equal masses of the liquids into measuring cylinders, then the volume of liquid A is twice the volume of liquid B. The volume of liquid B is twice the volume of liquid A. And liquid A is the same, the volume of liquid A is the same as liquid B. Which one of these do you think you can eliminate immediately? I would say this one, the last one. Because if they have different densities, they can't have the same volume if they have the same mass. That's ruled out. So we're left with 2. Now, if the density of liquid A is twice the density of liquid B, we would expect that if they have the same mass, then liquid B will have greater volume. Remember what we saw? When they had the same mass, the one with the smaller volume, the smaller density had greater volume for the same mass. So since liquid B has a smaller density than liquid A, we would expect that the volume of liquid B would be greater for the same mass. And so we would say that liquid B has twice the volume of liquid A, right? Based on what we have seen. So let's see that. Right we are. Okay? And this is all just based on our observations and using the observations in order to come up with the answer to the question. All right. Next question. Which of these has greater magnitude? Which of these has greater magnitude? A material, all right, 1.5 gram per cm cube or 1,200 kilogram per meter cube? Which of them has? And I want you to write down your answer, whether it is 1, 2, or none of them. All right? Again, could they have the same magnitude? Well, when I look at it, I see 1.5 and 1,200. Something tells me that they may not be they have the same magnitude, right? So it says none. That's not correct. So we left with 1 and 2. The thing that we have to do is to convert both of them to the same unit. And if we convert both of them to the same unit, then we can compare the quantities, how much of each unit we have, okay? And so what we can do is to convert the grams per cm cube, this gram per cm cube, to kilogram per meter cube, or we can convert kilogram per meter cube to gram per cm cube, and then we compare the quantities. All right, so let's do that. Let's do that. So we can, remember we said that 1 gram per cm cube, remember we said that 1 gram per cm cube is equivalent to 1,000 kilogram per meter cube. So 1 gram, and I'm going to write it in scientific notation, is equivalent to 1,000 kilogram per meter cube. So let's convert 1.5 gram per cm cube to kilogram per meter cube. So 1.5 gram per cm cube would be equivalent, and we must multiply this by 1,000. So this would be 1,500 kilogram per meter cube. Okay? So 1.5 gram per cm cube is 1,500 kilogram per meter cube, which is certainly greater than 1,200 kilogram per meter cube. Okay? So here, that would give number 1 would be the correct answer. All right? So here, let's see. Hooray. We're good. All right? So the next, all right, so the last one, I will go through this very, very quickly. The density of lead is 11,300 kilogram per meter cube. What is the mass of a sample of lead with volume that? Now, what we have is density. We know that, little density is equal to mass over volume. And so if we want to find mass would be, density is mass over volume. And what we're finding? We are finding density, we're finding volume, right? So density is mass over volume. So mass is equal to density times volume. And we know the density is 11,300, and we will time that by 0.001. And that will give us 1.13 kilograms. All right? We ran through that a little bit, but thank you. That's it for today's lesson. Be sure to practice and do some reading on your own until we meet again.